Right, this is the quadratic parent function. We are going to take our values that are in column x and we are going to square them. So if I take a negative 4 times a negative 4, I will get a positive 16 because a negative times a negative is a positive, and 4 times 4 is 16. Then if we take negative 3 times negative 3, we will get a positive 9. Because again, negative times negative is a positive. 3 times 3 is 9. We'll do the same thing for 2. Negative 2 times negative 2 gives us a positive 4. Negative 1 times negative 1 will give us a positive 1. 0 times 0, of course, anything times 0 is 0. Now we're going to take a positive 1 times a positive 1. It still gives us a positive 1. And they're asking what number times itself gives us 4. Well, we're going to use the rules of symmetry, and so let's see what happens if we have a 2. 2 times 2, positive 2 times positive 2, that does give us positive 4. And then we're going to do the same thing for 3. 3 times 3 gives us 9. And positive 4 times positive 4 gives us positive 16. Okay. Once we finish that, we'll want to plot these points so that we can see what they look like as the parent function. So I'm going to go and set my axes so they're much more easier to read. I'm going to space out the axes by 2s. So like I said, they will be much easier to read. So we're going to put down here it's negative 2 and then negative 4. And then the positive 2 and positive 4. And then we're going to do the same thing on our positive y-axis. So this is 2, 4, 5, mark 6, 7, 8, label 8, 9, 10. Just looks much more neater when you do it like this. 12, 13, 14, and then 15, and then 16. Okay. Now we're going to go to our x-axis, and the input is negative 4, but the output is going to be 16. So we're going to put a point up here at that junction, negative 4 and 16. So, and we're going to mark them off as we go. So negative 4, just traveling right on up, putting it up here at 16. Mark that off. Negative 3. We're going to go to 9. It's a good idea to mark as you go. Negative 2, positive 4. Plot the point, check it off. Negative 1, with the output of a positive 1. And 0, 0. And then 1 and 1. And 2 and 4. So we can see as we go along, since we will have a point on each side that matches, kind of like a little pair of socks there. Okay, so they match, they're paired up, and we're going to connect the dots. Okay, almost there, halfway around. And we have graphed our parent function. Now there are different forms that you will run into. The first one is the standard form. Standard form. So underneath your table, you're going to write these 3 things down. The first one's going to be standard form. Standard form of a quadratic equation. Since I get another pen because this one is dying. So we're going to have a coefficient of a that is associated with the x squared term, plus a coefficient b associated with the first power term, and then the constant c. That is your standard form. Okay, and then we will, in this case, we have x squared, 1x squared plus 0x's plus 0. So it could be written as standard form, in that way. And then if you just simplify it by taking out the 0x and the 0, we just have x squared, and then the assumed 1. Okay, we also have the factored form. We have been dealing with a factored form with our rabbit problems. So we also deal with them today, for our do now. So factored form, we have our roots, and so x plus 0 and x plus 0. You will have two factors because this is a quadratic. You will have two factors. If you have repeated factors like this, you could also write it as x plus 0 squared. But you can only do that if your factors are the same. All right. And then finally, we have vertex form. So let's change color here. Vertex form. As it states, we will have the vertex embedded in it. So x minus h plus or minus k, or x minus h squared plus or minus k. All right, where the h, the opposite of h plus k, and whatever the sign of k is, will be your vertex. Okay. In our case, our vertex was 0, 0. So, all right. So now we've got our parent function that we have over here, and we're just move that over, and it says we're going to shift that up 2 units. So we're shifting it up 2 units. I'm going to mark where the vertex is and where the 2 legs of the parabola cross out of the graph. So there's the vertex, and then I'm going to mark here. Okay, we are on the side that says worksheet page 24, and I just went ahead and labeled these A, B, C, D, and so on, so you'll be able to reference them. All right, then we're just going to connect those points here in a second. Okay, let's go ahead and use our parent graph. If I go over 1, I also go up 1. Now let's go, and we're going to use the properties of symmetry to go over 1 and up 1 from our vertex. Okay, then from the next point, we have to go up 1, 2, 3, and over 1. Okay, so I'm going to go from that point, 1, 2, 3, over 1. And then I'm going to use that line to go 1, 2, over 1, and we're just going to connect those points right there. Okay, so our function is that we start out with x squared, and we just added 2 to it. X squared, add 2, shifts it up 2, okay? All right, I'm writing down the points as our reference so we can see this. So we have 1, 1, and 2, 4. Over here, I've got 1 and 1, 2, 3. So 1 and 3. And our output for 2, 2, 3, 4, 5. There we go, 6, 2, and 6. So our tables would show that our x's remained the same, but we added 2 to our output. Our vertex is still at 0, but it's been shifted up 2 units. Axis of symmetry, x still equals 0. And I should have left myself some space to put in f of x equals x squared plus 2. All right, on to our next one. We've got x squared minus 3. So we're going to extend that from what we had before where we added 2. I'm just going to use our quadratic parent function, and we're going to subtract 3 from our values. So if I come over here to 3, add that, I'm going to come up here to 6. There we go. Okay. And then if I go to 2 and I subtract 3, I get 1. So I'm going to go to negative 2, go up 1, put a point there. If I go to negative 1 and I subtract 3, that's going to make it negative 2. And then if I go to 0, my output on the parent graph was 0, so I'm going to subtract 3, 0, 3, put it right there. And then when I go to 1, 1 subtract 3 is also still negative 2. And again, I could use the properties of symmetry from here on out. So 4 subtract 3 would be 1. And finally, 9 subtract 3 would give me 6. And we're going to connect all those points together. Okay, our vertex, our x is still 0. Oh wait, let's do our transformation first. So our transformation was, come on. We go down 1, 2, 3. There we are. Okay. Transformation. Shift down 3. Okay, our vertex still occurs where x is 0, but it's down 3. So negative 3, 0, negative 3. Axis of symmetry, x is still going to be 0 because that's the first point, that's the value of the first value in the axis of symmetry. Okay, now with this next one, we have that the negative 3 is in parentheses. So I first of all went and found out what the maximum is for my little graphs. And if I take 0 and subtract 3, I get a negative 3. Negative 3 squared is 9. It's too large. That's going to exceed my 7. So let's try 1. 1 subtract 3 gives me a negative 2. Negative 2 squared gives me 4. That's okay. So I can put that in there. So there's 1 and 4. Okay, remember I said you need at least a minimum of 3 points, one of them being the vertex. So let's put in 2. 2 minus 3 gives me a negative 1. Negative 1 squared would give me a positive 1. Sorry about the autofocus thing on my document camera, guys. Okay, so negative 1 squared gives me a 1. Let's put in 3. 3 subtract 3 gives me 0. Of course, 0 squared would give me 0. But I'm still doing the work over here just to make sure. Okay, 4. Everything has been declining, so it hasn't hit its vertex yet and started going back up. Okay, so 4 minus 3 squared. 4 minus 3 gives me 1, and then we square it, we get 1 there. Now I have my vertex, okay? We already know how that works, so we're going to go ahead and just come on over here and start graphing it. So we decided that 1 was our first point. 1 and 4. Put the point there. And then 2 and 1. Okay. Let's plot that one. And then 3 and 0. Remember, it's a good idea to check your points off as you go. And then 4 and 1. See that symmetry there? And then 5 and 4. connect the dots. And then we'll check here in a minute what our transformation is. Okay, so there's our parent graph. Now to get over to it, I have to go in this direction. 1, 2, 3, and now it matches. That direction is right. So our transformation is shifted right 3 units. Okay, our vertex. Well, it's no longer at 0. Our vertex now occurs at 3 and 0. And then our excess of symmetry this time is going to be x equals 3. Okay. All right. Next one, they gave us a graph. The parent graph is graphed in a dash. And then the transformed one is the solid one. So I'm going to use my little overlay here so that we can see exactly what happened. Okay, there's a little. You see where they went down 1, 2 to get to that graph again. So we shifted it down 2. Our function is x squared minus 2. Vertex occurs at 0 and negative 2, which means our axis of symmetry again is x equals 0. And our last function that we are going to do today is graph f. This time they gave us the vertex 0 and negative 1. Okay. And we're going to use that right there. It shifted down 1. That's our transformation. So our function is going to be f of x equals x squared minus 1. And our axis of symmetry is going to be 0 again. Graph our points. Remember that we're going to go over 1 and up 1. And then we'll go over 2 and up 4. Or over, and again, another over 1 from our last point, and up 3. And since it's 2 away from the axis of symmetry, we go use that properties of symmetry and go over 3. Now let's see if we can go up 5. 1, 2, 3, 4. Nope, I'm going to be off the graph, so I'm just going to kind of estimate where that parabola length should be ending up at. Just use that as a reference. Okay, so if you have a just number out there, added or subtracted, it means add or subtract, increase or decrease, shift the equation up or down, shift the function up or down. And if it's in parentheses, what we do is we do the opposite of the sign. So if it is negative, we shift it to the positive side. If it's positive, we shift it to the negative side. If we're going to combine them, we first of all do the transformation that is standing outside by itself. So for instance, if it has x minus 2 in parentheses squared plus 7, we would first of all shift it up 7, and then we would shift it over plus 2 because I said x minus 2, and then from there you put your vertex there and then graph your points. Okay.